Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about one more example of the valid power spectral density. This is the previous examination question. The example is check whether the following function is valid power spectral density function or not. First bit is 4 minus 2 cos of 2 omega by 3 omega square, and second bit is omega plus 3 by omega power 4 plus 2 omega square. Coming to the solution, first bit solution, given that the power spectral density is 4 minus 2 cos of 2 omega by 3 omega square. So verify or check it if the given spectral density is valid or not using properties of the power spectral density. And what are that properties? One of the property of the power spectral density. The power spectral density is an even function of omega. That is, Sxx of minus omega is equal to Sxx of omega. If that condition is satisfied, as the given function is a valid power spectral density. Otherwise, not a valid power spectral density. So, first we can calculate Sxx of minus omega. In the given power spectral density, omega is replaced by minus omega. We get Sxx of minus omega is equal 4 minus 2 cos of minus 2 omega. Omega is replaced by minus omega by 3 into minus omega square. So cos of minus 2 omega is cos of 2 omega. 4 minus cos of 2 omega by minus omega square is omega square by 3 omega square. This RHS term is the given power spectral density, that is Sxx of omega. So now here Sxx of minus omega is equal to Sxx of omega. The condition is satisfied. The property is verified. Hence, the given power spectral density is a valid power spectral density. And coming to the second bit solution, given that the power spectral density is omega plus 3 by omega power 4 plus 2 omega square. Substitute omega is equal to minus omega, we get Sxx of minus omega is equal minus omega plus 3 by minus omega power 4 plus 2 minus omega square, which is equal minus omega plus 3 omega minus omega power 4 is omega power 4 minus omega square is omega square. So this RHS term is not equal to given power spectral density. Therefore, Sxx of minus omega is not equal to Sxx of omega. Now here the property is not verified. So in this problem the power spectral density is not an even function of omega. So hence the given power spectral density is not a valid power spectral density. This is the procedure we can determine the given function is valid power spectral density or not. So this model is very important model problem.